Today we will talk about sequences. So just a little introduction to sequences. The Fibonacci sequence is investigated by Fibonacci. He's an Italian mathematician from the 13th century. It's an infinite series that looks as such: 1, 1, 2, 3, 5, 8, 13, etc. And to get the Fibonacci sequence, all you would do is you would add the previous two numbers to get the next term, which is really clever. The Fibonacci sequence is also referenced in films such as the Da Vinci Code. And the terms are the range for the function. Okay, so notice the sequence itself is the range, versus the term number, that is the domain, and it is a positive set of integers. And we can also write it as a function notation. Okay, so the f of in parentheses just represents the term number, and the actual term in the sequence represents what that term is in the sequence. For example, the first term is 1, the second term is 1, the third term is 2, the fourth term is 3, the fifth term is 5, the sixth term is 8, etc. Now, when we actually start talking about sequences, we use an A with a subscript. So A sub 1, A sub 2 for second term, A sub 3 for third, A sub 4 for fourth, A sub 5 for fifth, A sub 6 for the sixth term. Now, a finite sequence is a sequence whose domain consists only of the first n positive integers, meaning it stops. Okay, so the Fibonacci sequence, as discussed earlier, is an infinite sequence because it will continue going. And now we're ready for our first type of problem, in which we're just going to write the first 5 terms of the sequence. So when we write the first 5 terms, I'm just going to replace everywhere that you see an A with a 1. And then we simplify. We know 3 times 1 is 1, or sorry, 3, and 3 plus 4 is 7. And now we can do the second term. So this time we'll replace wherever the n is with a 2. 3 times 2 is 6, 6 plus 4 is 10. And then we'll do the third term. So we're just going to replace the n with a 3 and simplify. 3 times 3 is 9, plus 4 is 13. And we have our fourth term, 3 times 4 plus 4. 3 times 4 is 12, 12 plus 4 is 16. And our fifth term, 3 times 5 plus 4, 19. And that's all you have to do. If we look at our next example, it is a little bit more complex, but the same thinking process applies. So the first term, we're going to replace all n's with a 1. Okay, so negative 1 to the first power we know to be negative 1. 3 to the first is 3 minus 1. So this one gives us negative 1 over 2. Let's look at the second term. This time we'll replace all the n's with a 2. We know negative 1 to the second power is 1, and 3 squared is 9 minus this one will give us 1 over 8. Okay, let's look at the third term, a sub 3. Negative 1 cubed over 3 cubed minus 1. Negative 1 cubed is negative 1. 3 cubed is 27, take away 1. Negative 1 over 26, the fourth term. A sub 4 is negative 1 to the fourth over 3 to the fourth minus 1. Negative 1 to the fourth is 1. 3 to the fourth is 81 minus 1. 1 over 80. And now our fifth term. Negative 1 to the fifth over 3 to the fifth minus 1. Negative 1 to the fifth is negative 1. 3 to the fifth is 243 minus 1. Negative 1 over 242. And notice something unusual about this one. So this negative 1 to the nth power Notice that your signs alternate. Okay, so whenever you see like a -1 to the nth power, or n-1, or n+1 power, you should anticipate the sign will change. Please take a minute or two and try this example you try. Hopefully on letter A you found the first term to be 7, second term 9, third term 11, fourth term 13, and fifth term 15. And in letter B, the first term -1/3, the second term 1/5, the third term -1/9, the fourth term 1/17, and the fifth term -1/33. Now let's try B. So our first term, -1 to the first times 1 minus 2 over 2 times 1 plus 3. So we just replaced all the n's with a1. And now we're going to simplify. -1 to the first power is -1 times 1 minus 2, -1/5 for 2 times 1 plus 3. This ends up giving us +1/5. Second term, -1 to the second power times 2 minus 2 over 2 times 2 plus 3. -1 to the second is a +1. 2 minus 2 is 0 over 2 times 2, which is 4 plus 3 is 7. This would give us 0. A sub 3. -1 to the third power times 3 minus 2 over 2 times 3 plus 3. -1 times 1/9. -1/9. A sub 4. -1 to the fourth times 4 minus 2 over 4 times 2 plus 3. Okay, -1 to the fourth is +1 times 2 over 8 plus 3 is 11. So this would be 2/11. And then our fifth term, a sub 5, -1 to the fifth times 5 minus 2 over 2 times 5 plus 3. -1 to the fifth is a -1 times 3 over 2 times 5 plus 3 is 13, or -3/13. And that's it. Now I would like you to take a minute and try this example you try. Notice that you're only finding the first 3 terms. Okay, so hopefully on letter A you found the first term to be 0, the second term to be 2, and the third term to be 6. And for letter B, hopefully you found the first term to be -1/3, the second term to be 1/2, and the third term to be -3/5. Next, we will talk about factorial and what that means. Well, all a factorial is, if n is some positive integer, n factorial is defined as, I'm going to take that number and then multiply it by n minus 1, and continue to count backwards until I get to 1. A special case, 0 factorial equals 1. And if you look off to the right, we have a table for some factorials. 0 factorials, 1, 1 factorials, 1, 2 factorial, 2, 3 factorial, 6, right? Because 3 times 2 times 1. 4 factorial, 4 times 3 times 2 times 1, 24. 5 factorial, 5 times 4 times 3 times 2 times 1, 120. 6 factorial, 6 times 5 times 4 times 3 times 2 times 1, or 720. Okay, so just a little side note, and notice in our first type of problem, we're going to write the first 4 terms of our sequence. Okay, so A1, 2 to the first over 2 minus 1 factorial, or 2 over 1 factorial, which is 2 over 1, or 2. For our second term, 2 to the second power over, whoopsies, hold on, I made a mistake. It should be a 1 factorial, this should be 0, which is still 1, it's still 2. Okay, sorry. Moving on, 2 minus 1 factorial, 4 over 1 factorial, or 4 divided by 1, 4. Third term, 2 to the third power over 3 minus 1 factorial, 8 over 2 factorial, or 8 over 2 times 1, which is 4. And for fourth term, a sub 4, 2 to the fourth power over 4 minus 1 factorial, or 16 over 3 factorial, or 16 over 4 times 3 times 2 times 1. 2/3. No. Oh my goodness gracious. Keep making silly mistakes. Let me fix it. Okay, so 16 over 3 times 2 times 1. That looks better. 2 into 16 is 8, so 8/3. Take a minute and find the first 4 terms of the example you try. Okay, so hopefully you found the first term to be 3, the second to be 9 over 2, the third also 9 over 2, and the fourth 27 over 8. Okay, so we're going to evaluate each factorial expression. Okay, so in this expression, we know that I can write 14 factorial is 14 times 13 times 12, 11, 10, 9, 8, 7, and all the way down to 1. But if I can avoid doing that, I can. Now, obviously, if you wanted to write it as such, you're more than welcome to. But it will take a little bit more time, and it is a few more steps. Okay, so 2 factorial, and then you have your 12 factorial. Okay, and then notice what happens here. So we can cancel a couple things out. Notice they all have a 12 through 1. And we know 2 goes into 14 7 times. So our final answer here is 7 times 13, which is 91. Now, instead of writing all of that out, couldn't we have just done 14 times 13 times 12 factorial? We know 2 factorial isn't much to write, and then we have 2 12 factorials. And then notice these would cancel. And we do get the same answer. Okay, so you can kind of pick how you would like to simplify. Okay, so if we look at B, it is a little trickier, okay? So one thing that you can note, right, we do know something like 6 factorial, right? We know that is the same thing as 6 times 5 times 4 times 3 times 2. Or I can say n is like the 6 and n minus 1. Well, 6 minus 1 is 5 factorial. So I want you to think of this next problem in a similar manner, right? So it's like the 6 matches, whoopsies, the 6 matches with the n and the 5 matches with n minus 1. So if I have 2n plus 1, okay, couldn't we write it as 2n plus 1 times 2n plus 1 minus 1, because it's a term fewer factorial. In the denominator, we want it to be 2n. Okay, so notice that when we simplify here, the 1's cancel out. And do you see how now we have our 2n over 2n, right? So now we can cancel out the 2n's. And so we're left with our final answer, 2n plus 1. Take a minute and try these example U-tries. So hopefully in A you found an answer of 15, and in B, n plus 1. Yay, it's time to do some practice. The end.